We're graphing quadratics from vertex form today. So you look at this quadratic, and remember a quadratic is just any equation that has x squared as its biggest term. So in this case, this is what we call vertex form. If you remember, the three different forms we have are vertex form, standard form, and intercept form. And the name of the form tells us what we see in this form. So this form tells us the vertex right away, and then we have to find other things from that. So the first thing we look at is if you think about this as a transformation, remember our parent function is y equals x squared. So our parent function here would be y, let's see, I'll just rewrite it, y equals x squared, right? That's our parent function. And then what did we do to it? So inside the function we have minus 5, and outside the function we have minus 4. Okay, so if you remember transformations, what this means is we took our parabola, our parent function, we moved it right 5 and down 4 because x always lies, because your x is a liar. So instead of going left 5, like I would think it would be, I'm actually going right 5. Okay, so I'm going to take the parent function, which remember the pattern of our parent function. We start here at 0, 0, we go over 1, up 1. And from the vertex, we go over 2, up 4. So this is our parent function. Now we're going to transform it by moving it right 5 and down 4. 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Okay, and then since there's no vertical stretch or compression, it didn't change the pattern at all. So all we do is go right 1, up 1, right 2, up 4. 1, 2, 3, 4. We do the same pattern that we would do because there is no vertical stretch or compression. And there you go. That's our function. We graphed it. Now let's figure out what the different features of this function are. First, we have the axis of symmetry. Remember, the axis of symmetry is just this line that goes straight down the middle, straight through the vertex, and we could fold our parabola over across it. So where is that? Well, that's at x equals 5, because it's the same as the x coordinate of our vertex. Now, if you remember, our vertex is at 5, negative 4. Our direction of opening. So remember that transformations tell us whether it opens up or whether it opens down. If it's going to be our straight parent function and we didn't do anything, we didn't multiply it by a negative 1, it's going to be opening up. If we did multiply it by a negative 1, it's going to be flipped down. So this goes up because our a value here is just positive, right? So this opens up. Our minimum or our maximum value, well, that's the lowest point on our function, which is here. And remember, minimum or maximum is just a y value, so we're going to say that our minimum value is negative 4, and we could even write that that's a minimum. Our zeros. Now, our zeros on this one happen to be really easy to see because we were able to graph them during our, graphing of the pattern. So our zeros here are right here and right here. So we have at 1, 2, 3, 0, and at 7, 0. Those are our two zeros. And then our y-intercept, this one we can't see on the graph, but remember for our y-intercept, we set x equal to 0. So when I put x equal to 0, I have y equals 0 minus 5 squared minus 4. So that's 25 minus 4, which is 21. So my x-intercept is 0, 21. And that means that this is going to cross the y-axis at that point. And you're done. That's all you need to graph a quadratic in vertex form.